Have seen, we're now really turning to how open science can maximize the impact and value of research for our society. So we'll go a little bit more into depth. And we're going to start with it first. So on the other side of the stage, if I may ask Ms. Ritter, could you share your views on why open science is so critical to build sustainable societies? And can you approach this point also from a historical and cultural perspective?
Well, goodness, I think a lot of what we've heard already this afternoon really stresses the importance of it. I think, well, just very simply, the real problems that the world faces today, and we've had some great presentations on the SDG, the goals, and many other aspects, they're global problems. And they're urgent global problems, so we have to work together, and we have to work together really fast. And I think open science is the way to do it. I think Europe is in a unique position, and I think it has been, in fact, for quite a long time. There's some really interesting work that's been done by a researcher called Joel Mokyr, looking historically at the origins of the Industrial Revolution in the 17th and 18th centuries, and suggesting that although there was new technology in many countries across the world, the only part of the world where there was openness in the Enlightenment was actually in Europe. And so his theory is that it's the combination of the openness and the new technology and the new knowledge that actually led to the Industrial Revolution. Now that had huge benefits, but it's had huge deficits as well. And obviously a lot of the climate change that we're addressing right now is the results of it. So I guess we in Europe have a responsibility to clean it up, as well as actually having the ability to do that, because Europe still is very open. There's no other part of the world where in the EU there are 28 countries, and I must say I sincerely hope it stays 28. Coming from the UK, I certainly don't support Brexit. But there's nowhere else in the world where 28 countries work together in the way that they do in Europe, across boundaries. And I think this is an amazingly open community where we can do it. And just to finish on Brexit, whatever happens, certainly I and my academic colleagues really value the collaboration with colleagues right across Europe.
Exactly, and hopefully there will be some kind of solution found. I'm very confident there will be a solution for sure. And as you actually pointed out, we kind of owe it to our grandmothers, to our grandfathers, to keep up this open science, because it seems to be kind of in our natural DNA. However, there are still a couple of barriers that need to be tackled. And what are the main barriers that we need to tackle from your point of view?
The RISE group, it actually was a great experience. We sat down with a completely open book and then brainstormed about what we thought the barriers were for open science. And we came up with 4, and you've heard about many of them already. There was open access and the problem that so much data or so much knowledge is behind paywalls. There was open data, which we've just heard about and how important that is. And the fact that there is actually a lack of experience and a lack of training in how to use it and how to present it. There's research integrity, that we have to have reliable and reproducible data if it's going to be useful for open science. And then the 4th, which I think is almost the most important in many ways because it's the driver, is that the way we live at the moment, competition is good in research, but too much competition, extreme competition, is perverse in that it actually pushes you towards secrecy and not openness. And so we spent quite a lot of time looking at the impact of that, particularly via the funding mechanisms where success rates in grants are very low, in getting papers published, as we've heard earlier on, and actually in the whole assessment of researchers' careers.
For sure, yeah, and I think these are very important points to tackle. Camilla, you wanted to?
I think one of the biggest barriers to open science or to get open access is actually the way how we evaluate the scientists for funding or for positions. Because on the one hand, we are mandating open science, and researchers actually really want to do it. They want to fulfill those mandates as well to get the grants. But on the other hand, like when they are supposed to get a grant or they're supposed to be promoted for a tenure position, it's actually how they're being evaluated is based on where they have published. And that depends on the impact factor of the journal, and you're supposed to publish in the highest impact factor journals. And today, those are, because they've been around for 100 years, subscription journals.
Yeah.
So on the one hand, researchers are hearing publish and make it your research openly available, but on the other hand, to get the money or to get that job, they need to be publishing in certain journals. So I think that is a big dilemma today, but there's as well a very simple solution to this dilemma. We got to start moving towards evaluating researchers really based on the impact of their work. So how many views, how many downloads are their articles getting? How many views or downloads is their research data getting? How many citations are their articles getting? You can have today, like with that type of data that I presented as well, compare researchers within a cohort, within like a certain age group, within a certain field, and you can see like the percentiles. You can sort them. And like how impactful is this researcher? And that's based on real quantitative, hardcore data, rather than in a political decision, like where did they publish or not. And if we move towards that, we will have open science overnight.
Okay, thank you for that. Would you echo that, Mary? And what are your suggestions for that formulation of academic research career evaluation?
Yes, I agree with that. We have to get away from the very simple metrics and, this person's got 5 papers in Nature and 2 in Science, they must be really good. But I think it isn't just metrics, and one of the conclusions that we came to from our group was that you have to get away from not only the citations that's just been mentioned, and also the sheer number of papers, because also it's said, 400 papers, what a prolific or what a very productive scientist. And it's sort of salami slicing of the research. And then actually a better way would be to say, for a particular job application or for a research grant proposal, is name your top 5 publications that you think make the most significant contribution in this context, and then write a narrative around that, describing what it contributes. And that way, it gets away a lot from the metrics, and actually the responsibility is on the people on the panels assessing as well. Not to be lazy, and actually to think and to read all those papers and really assess the quality of the person and the science that they make.
Yeah, it would be a very all-comprehensive self-evaluation that could be very important there indeed. If I may turn to Mr. Killier. I don't know if you have a microphone. Great. Very good. So you're a leading researcher in biodiversity informatics. You're a leading researcher also when it comes to ideas with regard to open data in Estonia. And you're the founding father of the Pluto F initiative. So can you tell us a little bit more about this initiative and how this feeds into the discussion?
Yes. Okay, we will go to the roots now. But I like these 5 data metrics very much. Yes, when I was starting to work with maybe not big data, but data became quite big in the middle of 90s for biology when molecular methods became available. So we started to have many issues with data. And if I may explain how we work today, you can imagine we have some kind of timeline for the research project. We start, sometimes before funding, we collect data, we create data, and in the end of project or sub-project, we would like to publish our study based on those data. So we submit our data, and publisher will ask data sets today. Most important journals, they all ask today that we release our data sets in public archives. And we do this. But this is happening in most cases in the end. So you can imagine researcher jumping to another project, collecting new data sets, writing already new papers, and people are leaving this project. So those people are in hurry to find data from different computers, from different data sets, and then they make them open. And you can imagine, they are not complete, they are not linked, they are not following common international standards, so they are not atomized, and you can reuse them, but you have to invest a lot of money and time if you want to reuse them. So what we did, we took the same timeline and we developed tools, archives for biodiversity data management, so that we took archive from the end to the beginning. And we tried to change culture so that people started to upload their data to the archive from the beginning, so that data will be linked and not fragmented, reusable from the very beginning. So in the end, you just, project leader, push button and data will go to the different data repositories. And you can go on with data management. But it was difficult.
Yes.
Because the culture is different still.
Yeah. I can imagine, I think we all live by this whole FAIR principle, as you said. It was hard to find complete data sets, although it's very important that they're all very interoperable, accessible, reusable, and fairly used. We just said, okay, we made it easy. We created a platform, we created an archive where people can upload their details. Are they willing to do so, or are they still a bit afraid?
It's not easy, it's opposite. You know, those data, they are so complicated, sophisticated, which are collected today, that it's very difficult. And this is one, I think, wall, that they are sophisticated. It's very difficult to manage. So what we found out that there are a few old people. I just told that there was 87 years. He's still working with data sets, mobilizing very old data, actually written in Russian, openly accessible, but written in Russian, maybe not that. So, and making data sets and releasing for the global repositories. But I think what we did, few years ago, we decided to turn to young people mostly and train them, because we realized that it is very difficult to change culture in people like myself, so quite old already. So it's better to turn to the young people, which means, of course, it takes time.
Well, then welcome to Brussels, because lifelong learning is one of the hugest credos here. So we do invite you to still change and make it work, for sure. If I may just, because you already approached the topic of the young people and training them and educating them in the right way, I think Moritz from the Global Young Academy, he can tell us more about that, I'm sure. So what are the barriers for young researchers to really fully embrace open science?
Well, I think open science changes the whole system in which we do and evaluate science. So for early stage researchers to fully embrace open science, at the moment the risk is considered too big. Going into open science takes time and effort. So why would you do that, investing this time and effort, and we come back to the competition, if your competition takes that time, that effort, and on top of that, the results you produce to be evaluated against the criterion that are usually faced for promotion. So that is at the moment the biggest risk for early stage researchers to embrace it. There are a couple of ideas already being addressed of how to address that. One is creating awareness about, for the early stage researchers, what tools are available, so they don't have to reinvent the wheel, meaning they don't have to spend time and make open science a project in itself, but rather can focus on what they actually want to do, address the sustainable development goals, for example. Then the evaluation system needs to be addressed, and that requires also education not only of the young, but also of the senior people. And eventually, as you said, the early stage and young researchers are driving the open science change, revolution, or whatever you would like to call it. So one has to ensure that they're not only on the bus, but actually driving or co-driving the bus.
about a kind of a reward system. I mean, it's very time consuming, it's very hard. Can't you reward those people that take out just a little bit more time to work for this goal of creating this open science?
I think this is a very, very good question. It comes back to the core, which we're often discussing among the Global Young Academy and others, is what creates a creative environment that unleashes the best ideas, and are there actually metrics? Or I think since we're spending taxpayers' money, there should be some metrics, but how can we decide and design those metrics in a way that they are actually unleashing curiosity, encouraging risk, and going back to the journal impact factor, not skew or are not as prone to skewing and self-optimization than the current risks we have. Science has many clever people in there, so they might find a way around any kind of evaluation system, but still, I think that is still at the core of the question of what are the metrics that are really rewarding not only a creative researcher, but also a creative research environment, because it's not only the researchers that are evaluated, but it's also the environment.
Okay, very good. Does anyone have a question about this specific part? Anyone from the panel that would like to react to Mr. Reader on this point?
Can I add?
Yeah.
I think 5 top data sets should be included as well.
Very good. Then we should definitely include that in the future. If I may, please come to Mr. Bereski sitting next to me. So we've already had a contribution from the health side from Michel Goldman. You also work in the health sector, but then mainly from the patient's view, I would say. So what are the benefits of open science to patients?
There's, I'm actually in the health sector, but I'm a patient. Yes. So that's, yes. And you know, this is, as I was listening to you, this was really so interesting because there are a number of points I would like to highlight here, both practical and also ethical, philosophical, if you like. You know that all over the European Union and in Europe in general, there's this huge push towards patient inclusion. This is now one of the favorite slogans in healthcare, and also in public healthcare and in research. We must include patients, patients must be involved, you have to talk to your patients, patients must be active participants. The European Medicines Agency requires for every committee, for every commission to include patient representatives in there. However, patients have no access to science because it's so prohibitively expensive that it's impossible for patient organizations or for NGOs to access science. And if you consider that I come from Hungary, which is not exactly the richest country in the European Union, Hungarian universities simply can't afford subscriptions. So absolutely no access, even though I'm also a researcher, so I also happen to be a scientist, I have no access. But there are practical ways around this, and you know, so here I am, a venerable scientist, someone who's really well known in the HIV field. I live with HIV. I'm a former substance user, whatever, and I'm like this patient champion, and I'm forced to steal every single day. So if I want to do my work, then I have to find ways around the system, which are usually illegal or borderline illegal, to get access to knowledge. To get access to knowledge which I am expected to disseminate to my communities, right? Because I'm a patient expert, I'm a peer helper. So one of my key jobs is that I disseminate knowledge to other people living with HIV and to other patient organizations. That's what I do in the European Patient Academy, which was one of the initiatives by the Innovative Medicines Agency. Initiative. So, but I have no access to this knowledge, so what do? We establish journal clubs. Do you do this at home as well? I mean, we establish journal clubs. Journal clubs are when people get together and we discuss papers, and we never ask the question, where is that paper from? That just doesn't come up, right? So we just pretend.
This is a book club 2.0.
It is, yes, it is. It totally is. Then also, you know what I do? I use my daughter's university account. My daughter happens to be an aspiring medicines researcher, so I use her account. Is this legal? Not at all. So I not only risk my own career, I also risk my daughter's career, but I must have access to these papers. So I have no other choice. We also write blogs about papers, and then suddenly in the middle of the blog entry, you will find a PDF of the paper. Is this legal? No. But do you have any other choice? Also no. So it's so unfair, you know, that on the one hand, there's this expectation from society and also from the science community that we have to include patients. On the other hand, this is exactly the audience that has zero access to science, and then I will not even go into the details with poor countries, poor universities, poor NGOs. NGOs are just by definition not rich. So it's, yeah, I'm sorry.
No, it's fine, definitely. And but I just wanted to point out, I mean, this is the other side of creativity. You have to be creative to get the information, whereas with the information that you already have, you should be creative in using the data for very sustainable outcomes.
But isn't this too much? Isn't this too big of an ask? I mean, haven't we done enough already? We also have to be creative with data and information. So why? Why is that? Why don't we just have access? So why not open access? It just makes so much sense. We also know, and this was also mentioned here already, that patients who are informed, people who know about their illness and who know about their treatment, have better health outcomes. It just makes sense.
Sure. Yeah. Okay. Thank you very much for this very elaborate contribution. It's good to know from your personal experience as well what the real obstacles are. And then you're wondering, can't we just penalize those people actually? I mean, European Commission courts, do you have competences to tell people and organizations, I mean, this is not the way to do science, we're not going to support this anymore?
Yes, you're the big policeman or woman. I don't think it works that way. I think, as I said before, it needs to be a bottom-up process. And what is happening here tonight is, for example, very important, that there is debates about this, that researchers are aware of the better, more credible, quicker science outcomes that are relevant thanks to open science. It's very important that these stories are told. I think what I feel is, especially with the younger generation, but not only, that there is a big frustration with this publish or perish paradigm in science. And researchers want to have impacts. They want a good career. They want to be celebrated as a good scientist. But they also want impact. They want to be relevant in society. And I think very often now, researchers are probably in an environment where they're told by their seniors, watch out, open science, not very credible, science, nature is probably better. And the young scientists, who should be very open to this kind of open science, are hesitating a lot. So I think what we need to do, what we want to do, and what we will be doing even more, is to provide incentives to the institutions, to the researchers, to the teams, to go in this direction resolutely. That's why open access to publications is an obligation in the framing program. Open access to data is not the default policy. We require all the consortia working in projects to have data management plans. We make the cost of these data management plans eligible, so that there is no problem of costs there. That means that there is money available for this. That also is an incentive for people to work on that. We see that there is an incredible need of skills development, training in this whole area of how to make data fair, how to use them. If we don't do that, if we don't have attention for that, it will take a longer time than we can afford, and we need to speed up in this. I fully agree that the reward systems in universities have to evolve. Very important, the evaluation system, the alternative metrics, more qualitative evaluation also of research and researchers. All that needs to happen. But what is very important, as I said, is also like we're doing here tonight, is talk about this. Bring out the good stories. That's incredibly important. Because that's when scientists will know that this is the way to go.
Exactly. You're in the perfect position to create the right framework conditions. And indeed, we're here to discuss them and to ensure that after Horizon 2020, FP9 will embark on this road for sure. Mr. Killian, you wanted to make a contribution? You were eagerly taking the microphone.
I was
all Mary, please, the floor is yours.
Just a very quick contribution, which is we discussed training and skills right across all the areas that we were talking about. And one of the conclusions we came to was that we're really good in universities at putting on skills programs for the young researchers, the early researchers, when they're doing their PhDs. And maybe in the first 3 years after that. And actually, the target audience is beyond that. You want to get at the mid-career researchers and the more senior ones as well, because they're the ones who set the culture, and they're the ones that are sitting on the research panels making the decisions as well. And how you actually put on a training program for a more senior researcher is quite a subtle, problem. You don't call it training, you have to call it something else. But you really have to do that, because it's not fair otherwise on the youngest people, who, as you say, are the most open to being open in science. They can't take all the responsibility.
Exactly. So you should create some conditions also where research from all levels come together, discuss and tackle the different issues together. Yeah. Moritz.
I can only reiterate that point, is that's felt by many early stage researchers we've spoken to, is that they want this to embrace this. They often bring the skills with it, openness, no pun intended, curiosity, persistence, to a certain level also the stubbornness to push it through. But again, they're in an environment, they have their mentors, they have their advisors, they have people deciding over their funding in the panels, where training and generating awareness of the benefits of open science and what it means to go down that route really can have for advantages. And the transition to open publishing, open access publishing, is, in my opinion, only part of it. I think we need a much larger institutional change, because otherwise it is moved to the early stage researchers with more training and even more training. I think you need IT literacy to a certain extent, like IT is permeating everyday life, to make open science not a research project in itself, but use it to actually leverage your research and to generate an impact.
So there should really be also solid management plan and rationale for the institution to embark on those roads. You just mentioned IT and technology, we'll come to that later. We first have a question from the audience. Can you please state your name and organization?
Yes, Alea López de San Román from the League of European Research Universities. So thank you very much for all the comments. And of course, I agree with the reward system of universities. We are already working on that. Incentives, skills, bottom-up approach. But there is a word that I've heard, but I think we should say much more often, that is funders. So if we want to achieve open science, we really need to convince the funders. This is also the approach followed by the European Commission with Horizon 2020 and open access. So let's make those funders make open access and open science compulsory or by default. So it should be also mentioned into the discussion. Thank you very much.
Thank you very much. Indeed, we very much focus now on universities, research technology organizations, we have the European Commission. Do you talk to the funders as well, Mary?
Yes, we do. And that's a really good comment from the audience, because I think the most extreme version of funders' driving behaviour is the Bill and Melinda Gates Foundation, where papers published that are from research funded by them have to be immediately open. And that actually cuts out quite a lot of the so-called top journals. But this is a very big funding organisation, and it will have a real impact. impact. And I think if other funders were as adamant and mandatory as that would really help. And I think for Europe, I mean, the ERC is a fantastic agency and so prestigious now that they could really drive a lot of behaviour across Europe. And we've also thought about funders in another context, actually going back to the very beginning of the competitiveness for grants, that whether it's by redistribution or more money, obviously more money would be lovely for research, but funding, a lot of it goes into big group funding rather than into principal investigators. And coming back to the young researchers, it's tough to get your foot on the bottom rung of the ladder if you don't belong to one of these big consortia. So more smaller funding and perhaps being very radical in terms of how the funding is allocated as well.
Thank you. I think Mr. Reski wanted to point something out to Camilla as well. More throughout, we have everyone engaged. And then we come to a question as well from the audience. So
I just wanted to... Sorry, go ahead, Camilla.
Okay. So I totally agree with what Marianne says. If the funders were mandated, like the Bill and Melinda Gates Foundation, overnight there would be open access. And there's no issue to quality or anything. Believe me, nature and science would flip.
Okay, clear.
So what I wanted to say that is, it's not just doom and gloom. There's also a handful of really good examples for how this works already in practice in some disease areas, including some cancers, breast cancer, some blood cancers, HIV, hepatitis, where all these stakeholders can work together in order to produce science, which is community-based and community-initiated science. You've been talking about citizen science. Well, this is it. So when researchers and pharmaceutical industry admit that they have no access to the right populations, but the patient community does have access to that particular population, then let's work together. And they have seen that this works. And so we provide that knowledge that we have from the community side. And just because we are patients living with a disease, whatever disease that is, that does not reduce my capabilities as a researcher. I was trained in methodology. I know how to do it. So my HIV or my breast cancer or whatever will not impact on my scientific capabilities. So let's do it together. And there are examples already for these kind of initiatives. So it's not totally unheard of. It's not like something that needs to be reinvented or invented, but it's there. Let's just expand or build on these models and make use of it. Exactly.
I'd like to pick up upon Mary just this early independence to try out something new. A few years back, the European Academy did a global survey on the state of young scientists, and they wanted to figure out what are their fears, what are the worries, and what are the opportunities early stage researchers see. And there were three notable, well, there were many, but one of them was mentorship. The other one was skills training for how to have impact, which is nowhere taught or not really taught. You just expect that either it comes with your gray hair or overnight. And the last one was earlier independence. And for that, early stage researchers, again, coming back to the generating impact and the open science approach. For them, they see it as opportunity to really have an impact. But as long as they're not independent, they can't really walk that way and walk new ways. And much of that area of open science, of this concept, of this idea, is still developing and worked out. So I think we need many more people actually walking those ways and testing and sharing what is working and what is not working. I think there are many early stage researchers around that would like to do that, and with the right level of support from the institutions, from the funders, I think we could see quite some activity there.
Yeah, so the will is there, but it still needs a cultural change also within the institutions, for sure. A question from the audience.
Yes, thank you to the inspiring panel, really. I think I have a question for Mr. Van den Bergen.
What's your name, organization?
I'm going to say. My name is Katrien Leskroat from Flanders Marine Institute in Ostende, in Belgium. quickly, our open access, open data is in the core of our institution, and we work together with IOC UNESCO for the training aspects of that. But the challenge is daunting. A few weeks ago in Science Business, it was mentioned that with the initiative of the open cloud comes the huge challenge of being able to digest all the data. So it was mentioned that the need of data scientists is tremendous. So you already mentioned a little bit, you said that we have to go quick. I imagine there are already some ideas. Artificial intelligence to address the big data is one of them. I would really be interested to hear your views, because I imagine that it needs a global strategy, or at least a common strategy to address this. Thank you.
Thank you very much.
Well, I can only agree. You're absolutely right. And that's part of our policy for creating this European Open Science Cloud, which is not only about federating repositories and making data fair, which of course is the beginning of everything. If we don't have that, there won't be a cloud. But there's a whole ecosystem around it that we have to take care of, which is the open science culture and evaluation and rewarding in institutions, but also creating the whole ecosystem for data analytics, so that this data can actually be used, that the quality can be checked. And that's something that we would hope can also be created by going in this direction of creating this European Open Science Cloud, which will need the mobilization, and that's the difficulty, the challenge for us. It's an exciting project, but it's very challenging, because it basically requires the mobilization of everyone that is involved. And that's the difficulty we have. It's the funders, it's the researchers, it's the data repositories, it's the big infrastructures, it's the governments, it's everyone. And getting all them aligned, working together, that's quite a challenge. But our commissioner is very clear that this needs to happen. So we'll be working on this. But you're absolutely right, the data analytics, the artificial intelligence will also be a condition for this to work.
Yeah, indeed, a very good point. And yeah, data scientists, I mean, what we've seen, and Camilla, you said so as well, I mean, the whole open science revolution has been there for about 10 years. It's only logical that these new kind of jobs, they still need to be further developed, and we need to base it on knowledge that we don't even have right now, and that's going to be a huge challenge. We've briefly talked also about the role of IT, which Stephen also mentioned, and then I'd like to come to Camilla again. Can you tell us more about the role of technology in driving the open science revolution?
Yeah, I think that technology is incredibly important. Without technology, nothing happens today. Well, there's of course the researcher's perspective, and you need to be literate in IT systems, whether it's open science or any type of science. Without software and computers, nothing works today. But I think, from our perspective, the publishing perspective or the provider's perspective, technology is as well incredibly important. As I mentioned, the volumes of the articles or of the data is growing exponentially. In open science or in open access, we're committing ourselves to publish everything that is valid science, and let the technology then evaluate its impact, or at least provide us with the numbers, whatever we do with it. But at least you get the quantitative assessment of it. So without technology, you can't actually publish this at an efficient way. The way that without technological support, you can't fly millions of planes daily from A to B. You would have havoc, basically. You can't just have pilots, sitting in the planes and hoping for the best to get us to New York from here. So we also cannot just sit around and have, the editors, as bright and as brilliant as they are, and we had today presentations from some of our chief editors, but they also cannot read every single paper and say, this is good, this is bad, here they've done the statistics right, these authors maybe have, with these reviewers a conflict of interest, here we have an ethical concern, etc. and so forth. We need technology in order to do that. So that's the type of software that we have been driving and developing over the past 10 years. It basically gives you readouts, based on keywords. For example, if you have a paper on vaccines, that may, be controversial. So it flags these things. It flags them to the editors. It flags them to the reviewers. They can double check on these types of issues. If a reviewer is from the same university as the authors, that might be a conflict of interest. It may not be a conflict of interest, but somebody needs to evaluate that. So all of these checks are basically in place. And without them, without all of this technology, we won't be able to move towards 3 million papers. I'm not just talking for Frontiers, but I'm talking now for the entire publishing industry. Towards 3 million papers or terabytes of data. It has to be curated, and the tools, the digital tools, need to be put in place.
Thank you. Just to stick to this technology, Mr. Killian, we really focus very much on the open data and also part of the Estonian Open Science Expert Group. Can you tell us more about the role of technology specifically for this field of open data? Because Estonia is one of those countries, as far as we know, and that's what we hear all over the place, you're the country of the European Union.
Thank you. I was not prepared for that question, so and I'm not sure that we are ahead of. I have heard actually here so much interesting, and actually one thing, maybe it will partly answer your question also, but I'm really positive about the young generation of people. I'm not calling them, at least in biology, data scientists. I'm calling them biologists in silico. And they don't go that much to the forest, to the meadows. Yes, that's maybe not that nice side, but I have seen 10, 15 years now how they have been growing and actually making their own career without any funding sometimes. And I can see that there is new culture coming up all the time, that we can have a commission in Estonia and we can make papers and rules, etc. But there is already a young generation coming up. And it's so funny, if I can have one example. So I will still go to the nature and look for the birds, and I can identify even Homo sapiens here in this room, so by my eye. And they are sitting and looking to the screens, and there are stretches of DNA, and they are talking to each other, and I'm listening and saying, this is this species, this is this. Why you think this? You see these nucleotides here. Oh yes, I remember. Yes, this is this species. So, can you see? And then they are cleaning up those data sets. They are taking them from gene banks, including European Nucleotide Archive. They are cleaning up and making them open again, updated, linked, everything. So, and it's happening. And they are talking to each other, and they are doing this. So, I'm not worried at all about open data, actually.
Very good, because there's always this individual curiosity to find out how we can leverage this open science. Thank you. Well, I think we have talked a lot about open science bringing us so many positive things, but it might also have some negative side effects. And Moritz, I believe you have a kind of opinion also on middle, high-income countries and how open science could be perceived there.
Yeah, well, in the Global Young Academy, we've got members from more than 50 countries around the world, and sharing, discussing, and working together at global solutions is a big topic. But when you talk about making all data available, then I sense some reluctance to a certain extent. And that reluctance, if I understand it correctly, goes back to a little bit of what happened to the natural resources in many of those low and middle income countries, that once they are out there, once they are known, someone else parachutes in and benefits from that, from this data. And I think there needs to be a lot of education, not in terms of on top of, well, there needs to be, in my opinion, a lot of education what it actually means to make one's data set open, what rights you can retain. There are lots of different licenses and models with various levels of restriction, and from very serious to very funny. There's one license called the beer license. If you meet the writer of the software, you have to buy him a beer or her a beer. But this is nothing an early stage researcher can really get an overview from. So you need, again, going back to the institutions, you need or somewhere a point of contact where you can get quickly the information you need, quickly the training you need to put it in place, that you really feel still empowered over your data and you have benefit. It's not taking away like natural resources where you don't have any local benefit anymore, but you really gain as well, and you see that you also can gain something via data. And that we come back to the fair principle. That word is not probably chosen for a purpose as well. That this works out not at the detriment of those who generate the data, but might not have the technical capabilities to spot hidden trends or other gems in one's data.
Exactly. So many steps still to be taken. Does anyone like to? Yeah.
These are very important points that you raise, and I'd like to draw attention to three aspects in this. One is that we need to find a good solution for making sure that the people who curate the data, put them in, can be identified. And there are techniques for this, unique identifiers, etc. And that needs to become really a standard practice. Just like you have in the publications, you have citations, the same should happen for data. I think there's still a lot of work to be done there, but we know in what direction to go. Second aspect is the whole regulatory framework of this. Makes it very complex. In May 2018, the General Data Protection Regulation will kick in, which will have enormous implications for how data are used, shared, taken up. We have the Copyright Directive, which is also creating all kinds of challenges. It's very challenging because it's very complex, especially with the GPRD. We're not the GDPR, General Data Protection. GDPR, thank you. There's still many open questions, so we'll have to work on this. But at the same time, it's also reassuring that there will be, at least at the European level, a coherent framework for this. And that's coming back to the Science Cloud. Another element, another dimension of the Science Cloud is that we need to be able to offer to scientists who make their data fair and use fair data, that they know that they are complying in an easy way with this whole regulatory framework. And the third aspect is the global dimension of this. Because we need to have at global level agreements, understandings, certainly with our major partners in the world, that this is to mutual benefit. And that's something we're doing through a G7 working group at the level of the G7 science ministers, with the help of the OECD also, where we're trying to come to global standards for open science, so that there is not this exploitation unilaterally, because indeed, to put it very cruelly, we don't want to have an open science cloud that is open to everyone, but then the use of this is going to other parts of the world only. There needs to be mutual benefit in this, so these are very important aspects.
Thank you very much. That would be the next step, of course. I mean, I think that Mr. Apogetta also pointed out there's a lot of potential there also for developing countries. It's a global discussion. European discussion, because everything is very much interconnected right now. So I hope that will be the next step as well to create global standards. I think you
Just
wanted to add
a single sentence to this, which will probably only add to the complexity of the whole thing, but I just want to feedback that in larger patient communities there's a lot of talk about data ownership when we speak about whose data is this, and there are many patients who are very sensitive about this, and they say, well, I give my blood and my tissue I give pieces of my body to science, so whose data is this, finally? And I don't expect this question to be answered now, but there's a lot of talk about this in patient communities, and I think it's a very legitimate ethical perspective that we should not disregard.
Okay, thank you very much. If I just may come back to your second point, which is a regulatory framework, because of course the framework conditions need to be set in such a way that you can progress. May I ask Camilla, what is your view on the latest developments, for example, the EU copyright reform, one of those regulations that are being set on?
Well, our position is very simple. When it comes to scientific papers, it just needs to be text and data mineable, and there should be no exemptions. It should be free to text and data mine, whether it's researchers or companies. Companies, as we are seeing, critically depend on science, technology and innovation, on this research, the scientific papers. Today, Europe's planning to build the Open Science Cloud, but very little data is actually available. So what do? We actually go and we mine papers. And we look at the results sections, and we mine out of hundreds and thousands of papers on a certain disease or so, all the different results, and put them together back into a database. For example, in the Blue Brain project, which my husband is running, Henry, and the Human Brain project, this is exactly what they have been doing, mining lots of papers because there's no data available. So thousands and hundreds and thousands of neuroscience papers to put it back into a brain model and then start simulating the thing. Now this is for the research, but if we want to have successful companies, economically strong companies, allow them to do the same thing. So our position is very clear, just make it all. It's funded by our research. It's my taxpayers' money that went into this research. I want to be able to benefit from it in any type of way without any exceptions.
Exactly. Yeah, Lawrence.
That might sound now a little bit strange, but again, from the discussion we had among many European young academies and the Global Young Academy about open data, we started actually the statement with not all data needs to be open, because research is such a diverse field. We always put it together as researchers, as scientists, but the diversity in these fields and also the requirement from the data are so different. We've spoken about patient data. To what extent should the personal identifiable patient data be online? And this is a very, very careful area that really has to be decided from case to case. We come back to artificial intelligence and we see how little data is actually necessary to identify individuals. So I think this is something that has to be very, very carefully considered. And that's why also, it might sound controversial, but that's why we started the statement with not all data needs to be open, because there have to be exceptions and that has to be evaluated from case to case.
Of course. But in order to do that, you do need to have critical people that can decide on what should be open and what could perhaps not be open. Ladies and gentlemen, we've almost come to the end of this panel. Unfortunately, I think we could have talked for hours still, but I'm sure you're also looking forward to the reception where you also have the opportunity to talk to the panelists. Just one final thing, and this is something that you have not prepared at all, but what I like doing for sure. Can you just give us one keyword to make open science a true success? Mary.
One key word. I think it's reward. I think you have, yes,
okay.
You have to reward people for it, and then you'll get the rewards for it
Thank
afterwards.
you very much.
Sorry, I have two words. I would say institutional change.
Okay. Thank you.
I'm going to steal Court's. Share, care, dare. The daring part in it is, I think, very important.
Thank you.
I would say make it exciting and celebrate successes.
That's a whole lot of questions.
I'm from the Commission.
Good point. We're allowed to do so, right? Yeah.
So almost everything has been said. So maybe freedom, I think. Freedom inside and outside, in institutions. Yeah.
I will say what I tell every student of mine. in the patient academy. And what we say to doctors, if you could learn it, I can learn it. It's just knowledge.
Very good. Thank you very much. And please give the panel a big hand.